Great, thank you very much. My talk's just going to be a summary. We've talked about a lot of the ongoing stuff. I'll fill in some of the details on how some of this stuff came around. So you can kind of think of my work. I'm kind of the quality control arm of the practice exam, of the performance exam, just to make sure the good product that was developed stays good and stays on target. So we'll talk about the kind of program of research around that. I do have some disclosures here. You can see by my numbers, I'm not a very good consultant. They don't use me very often, and nobody buys my simulator. So, and yeah, much like my dancing at the sing-off, my consulting fees are well below average. So. We talked a lot about FES, skills exam. One thing important for this talk is just to emphasize the two platforms that the performance exam that can be taken on currently. And we'll show later how some of our data kind of helped us reconcile an issue with these two platforms and kind of make the test more fair. And kind of highlights the importance of ongoing data analysis once you have your initial validity evidence. So you talked quite a bit already on the validity evidence prior to FES launch. Based on the volumes we do now, these were limited numbers of subjects. We showed good reliability, and then basically what we call relationship to other variables validity evidence, which in this case is tying it into actual colonoscopy performance measured directly in the workplace with the gauges score, which is a workplace-based assessment. And you see that even in this early pre-work, R value of 0.8, so you're explaining 60-some% of the variance in FES score by just colonoscopy measured performance alone. So a clear and deliberate tie to clinical endoscopy that has been reinforced quite a bit in this panel already. When we move forward from a test development standpoint, we try to identify and mitigate what we call threats to validity. And threats to validity generally fall in two areas. One is construct underrepresentation, so making sure you are accurately measuring what you want to measure. And I think Ezra's talked about that. The field changes, right? And you have to revisit that construct periodically to make sure that you're continuing to represent that. But this is really in the ongoing development process, and this has remained stable over time. The piece that we're going to talk more about is called construct irrelevant variance, and this is a concept where you're measuring things that aren't in that construct. Okay, so a good example of that would be if you took a written test in English and gave it to non-English speakers, you would be measuring mostly their English proficiency rather than their actual knowledge of that field, right? So that's a easily conceptual understanding of construct irrelevant variance. It's also, if you're from an engineering background, kind of noise, right? What you want to measure is signal, and construct irrelevant variance is noise. So we've kind of gone through a process to identify and mitigate some of these pieces in FES. So we looked at essentially the test performance properties of the performance exam, both right before the American Board of Surgery requirement and then in the period of time after the American Board of Surgery requirement through these two publications. And what we found, this was kind of referenced before, a continued strong relationship with clinical endoscopy experience. This is from the 2018 paper. And this is total endoscopy, so upper and lower grouped together. You can see the pass rates there go up consistently with experience, as do the mean scores. So that's good evidence of both what we call consequences validity evidence, and that's kind of around the cut score concept where the pass-fail score is, as well as relationship to clinical endoscopy. That's the pass score for reference. What we did identify that has kind of been a program of research for me since then is some of these potential threats. So 3 things that came out on analysis that are fairly strong predictors of pass rate are these highly collinear variables of gender, glove size, and height. So these, particularly with the 2017 data, completely unable to separate these. For example, in the big database, there's no male test taker who has self-reported a glove size less than 6.5, I think. So you can't say, okay, at small hand sizes, is there a difference between men and women? So this has been one of the issues going on, but this has been a consistent finding. This was showed previously. This is the visual abstract from the 2020 paper looking at 2,000 test takers, so this was after the board requirement. You see the continued relationship in the far left with clinical endoscopy experience. One of the things that we still have to address as a committee is the lighter blue box, which basically shows that each of these 5 subtasks essentially function independently, meaning there's not good psychometric evidence that you can compensate for one of these skills with one of the other skills. They're measuring independent skills required for endoscopy. And what that would suggest is that instead of scoring like Dr. Miller said that we have been, where you can compensate for poor performance on one task, there's considerable support that there should be individual cut scores for each of these tasks. And that's something that will obviously affect pass rate and something we need to work through from a policy standpoint, but that's the way the test is performing. One thing that we were able to correct quickly is some of the initial studies on the 2 different simulator platforms suggested that the GI Mentor Express may actually be a little easier to pass the test than the GI Mentor. And on this larger data set, we were able to say, no, that's not the case. They're performing essentially equally. And we removed the kind of penalty factor that had been factored into Mentor Express to make the test more fair. So one of the great examples of why you need to continually analyze your data. And then obviously the gender difference issue that I mentioned before, pretty consistent even in this larger data set. So we wanted to see pretty quickly whether that difference could be mitigated. So we actually reanalyzed the data from several different training studies that had utilized simulation-based mastery learning. So this is essentially focused deliberate practice on specific subtasks. And what we basically, all of these trials followed basically this same pattern. There was a pre-training assessment. Then there was simulation-based training on some of the platforms that you saw presented already, from the GI Mentor to the endoscopy training system to the STEP curriculum, and then a post-test. So what we found with that is, as expected, large gender differences in the pre-test on skills and pass rate, but then post-training, that difference is largely mitigated. And I think the mean training time in these trials was somewhere in the single digits of hours, 5-6 hours of focused, deliberate practice with coaching and all those things that were just highlighted. So we know whatever's going on here with this gender issue, it's plastic and it's overcomable. I mean, obviously there are lots of fantastic women endoscopists, so it's just a matter of focusing us on either how we're training this, how we're teaching people with smaller hands to do endoscopy, and as a committee, we're addressing some of this. We also have an ongoing trial at our institution looking more into this in terms of across different platforms, so endoscopy, laparoscopy, and robotics, with the hypothesis being that if there are ergonomic issues with endoscopy, robotics, for example, may completely mitigate that. But we just finished data collection, so I can't even give you a teaser on that one. So the simulation issue was presented a couple of times, and I'm just going to show you kind of how this came about. These are clips. If any of you are on the APDS listserv, there are periodic flare-ups of FES and FLS bashing that many of us have to juggle. And this was one day's conversation, basically, where there was a group of program directors who were essentially convinced that FES was not a measure of clinical endoscopy. As we've shown today, there's a huge body of evidence to support, but it is more a measurement of whether or not you practice on the simulator. So there's, this is an exchange throughout maybe 1 or 2 days, I think. And this really kind of drove me to be like, okay, we're gonna answer this question, right? I think the second comment, and I don't have the pointer, but the second comment to me, is interesting, and you'll see how this plays out. So this is a complaint that they don't have a simulator, so they have to use another hospital simulator. And the residents spent a fair amount of time doing this and failed the practical part. Well, I think you saw in the last talk, there's no direct relationship between unstructured simulator practice and passing the test. So, I mean, basically predicted what we would find on the data right there. You can't just unstructuredly do the simulator and pass. You got to do good structured endoscopy. So anyway, this led us to the papers that we already touched on, the first in JSE and then the second in Annals. And we kind of already saw this. This is the relationship between simulation training time. You can see that kind of variable baseline. These are mean scores here, right? It kind of up, down, no consistent relationship. You have this little spike at 11 to 20 hours. Not really sure what that means. But on the next slide, you see this is lower endoscopy. That red line is essentially the performance level of that 11 to 20 hour group. So you see it's not like they're way up here and getting some kind of an unusually good benefit from the simulator. They essentially are falling somewhere in the realm of folks who have done 50 to 100 colonoscopies. So this again confirms relationship to other variables, validity evidence. There's sequentially increasing pass rates as well as score performance with increased endoscopy experience. And one of the other things that doesn't get talked about as much is you can see the narrowing of the error bars as you go up, particularly in that 200 plus group. And it's not necessarily improvement at the higher ends, it's consistency, right? And that narrowing of those error bars is really one of the indicators that you're having expert type performance. So on our multivariable regression analysis, we looked at simulator experience both in our whole study group, which is here, as well as what we called a qualified resident group, so folks who had met kind of the minimum, and then what we called a typical resident group. So most residents, when they're finished, are gonna be in this band of experience. And you see across all these groups, simulation experience was not a predictor of pass rate, whereas lower endoscopy was consistently, gender, which we already talked about, and this tested on express was the issue we've already been able to mitigate. So take that off the table. So in conclusion, I think over the last, since this became a requirement and we've done this, our due diligence with monitoring our data, we can say with lots of confidence that clinical endoscopy experience, particularly colonoscopy, is strongly associated with both score and first-time pass rate. These 5 tasks do represent unique skills within the skill set of endoscopy, and we have to make some decisions moving forward on how this is going to be scored to ensure we're achieving our goal of making people better endoscopists. We do know now that we can score the FES the same across 2 platforms, which is helpful in ensuring this is a fair exam, as well as taking some of the administrative burden off of it and making the distributed test center concept that Ezra talked about more straightforward. And then the gender hand size issue that we have some ongoing work to look at, and that we know that's a plastic variable and will be reduced significantly with focused task-specific practice. So, finally, you don't need a simulator to pass. An unstructured simulation experience should not be expected to be helpful, but as was presented earlier, there are structured, focused simulation training pathways that can be used for remediation or certainly to assist skill development in conjunction with clinical endoscopy. Thank you.